Good day. In this video, we'll discuss the main components of flight control: the processor, sensors, output controls.
Communication modules, ports and interfaces, software and firmware.
The main processor is the central processing unit that runs flight control algorithms. It receives sensor data, calculates necessary corrections, and sends commands to engines and other systems.
Types of processors used include microcontroller MCUs for compact or small-sized UAVs. Additionally, MPUs, known for their superior computing power, are utilized for more advanced UAVs with artificial intelligence processing. Main functions of the processor: reads data from IMU and other sensors, calculates the position and orientation of the drone using algorithms like EKF extended Kalman filter, controls engines through ESC's electronic speed controls, processes GPS data for autonomous navigation and communicates with the operator via telemetry.
The main sensors are IMUs, inertial measurement units, consisting of an accelerometer that measures acceleration along the XYZ axis and a gyroscope that measures rotational speed on the same axis.
The data is used to calculate the UAV's tilt and movement.
Magnetometer. It functions as an electronic compass and detects the Earth's magnetic field. It's used to correct the drone's orientation, especially when GPS is inaccurate. Barometer. Measures atmospheric pressure and determines altitude accurately. Aids in maintaining constant altitude without GPS. GPS devices provide geographic coordinates for autonomous navigation. Some GPS units have RTK, real-time kinematics, for centimeter-level precision. ESCs, electronic speed controls, manage the speed and rotational direction of motors. They receive commands in PWM, pulse width modulation format, from the flight control. Servo mechanisms are used for auxiliary controls. Some flight controllers may also have hot swappable interfacing for digital control of ESCs.
The telemetry communication modules operate in the frequency ranges of 915 MHz and 2.4 GHz, which is quite adaptable. These modules intricately allow for the efficient transmission of detailed flight data to a ground station, utilizing different frequencies as needed to ensure seamless communication.
The radio receiver, RC receiver, receives commands from the remote and sends them to the flight control.
Wi-Fi, Bluetooth, 4G, 5G enable advanced telemetry and remote control through the internet used in industrial UAVs and
FPV. UART ports and interfaces, universal asynchronous receiver transmitter that communicates with GPS, telemetry, and other external modules. I2C. Inter-integrated circuit used for barometer and magnetometer sensors. SPI, the serial peripheral interface connecting fast accelerometers and gyroscopes. CAM, the control area network used in industrial and automotive UAVs for reliable and fast communication between modules. USB is used for configuration, software updates, and data transfer. Software used in UAVs are
ArduPilot, PigSwat,
Betaflight Nav. In conclusion, a flight controller is a complex system integrating sensors, processors, and communication modules to enable stable and autonomous UAV flight. Choice of controller depends on UAV type, usage purpose, and required complexity level.